Hi students, today let's see some important numericals on spherical mirrors. Let's discuss the sign convention also before we start doing the numericals. So all directions on the left side of the pole is taken as the negative directions and all directions on the right side of the pole are taken as the positive direction. Now magnification is given by the ratio of the height of the image and the height of the object. Magnification is taken as positive when the image formed is virtual and erect, and magnification is taken as negative if the image formed is real and inverted. So the first question is, find the size, nature and position of image formed when an object of 1 centimeter is placed at a distance of 15 centimeter from a concave mirror of focal length 10 centimeters. Okay. Now let's try to solve this. We have been given the distance of the object is 15 centimeter and the focal length is 10 centimeter, and we have to find the size, the nature and position of the image. The object is placed 15 centimeter to the left of the mirror and the focal length is also towards the left, so both are in the negative direction as per the sign convention. Now let's use the mirror formula. So the mirror formula is 1 by V plus 1 by U is equal to 1 by F. Now putting the values of U and F, we get V is equal to minus 30 centimeter. Now this minus sign indicates that the image is formed on the left side of the mirror. Now let's take the magnification. So magnification is basically the distance of the image by the distance of the object. So on calculating, we get magnification as 2. That is, the size of the image will be twice the size of the object. Now let's check the sign. Since the image is formed below the principal axis, so we will take the magnification as negative. Okay. Again equating magnification as height of the image divided by height of the object. So now height of the object, we know it is given 1 centimeter. So putting the values and equating, we get height of the image as 2 centimeter. And the negative sign indicates that the image is also formed on the left side of the mirror and below the principal axis. So the image formed will be real and inverted. Now if you draw the ray diagram, it will look something like this. So you can see the image formed is inverted and below the principal axis. Let's have a look at the second question. The second question says an object of 2 centimeter high is placed at a distance of 16 centimeter from a concave mirror and it produces a real image which is 3 centimeter high. Now you have to find the focal length of the mirror and you have to find the position of the image also. Okay. It is given height of the object is 2 centimeter and height of the image is 3 centimeter. So we can say the object is 2 centimeter above the principal axis and the image is 3 centimeter below the principal axis because it is a real and inverted image. So the magnification is 1.5 times and it is negative because real and inverted image is formed. Again we can take magnification as the ratio of the distance of the image and the distance of the object. Now let's substitute the values and do the calculations. So we get V is equal to 16 into minus 1.5, that is minus 24 centimeters. So the image is also formed on the left side of the mirror. Now let's do the calculation for the focal length. So we know the object distance is 16 centimeter on the left and the image distance is 24 centimeter again on the left. So we need to find the focal length, so we'll use the mirror formula. So now putting the values of object distance and image distance, we get the value for the focal length, and this is equal to 9.6 centimeter on the left side of the mirror. Now let's take a look at the last question. It says an object 5 centimeter high is placed at a distance of 10 centimeter from a convex mirror. Okay. Of radius of curvature 30 centimeter, find the nature, position and size of the image formed. Okay. If you look at the ray diagram, we can understand the nature of the image which is being formed here. So the image formed is real and erect on the right hand side of the mirror. Let's see the given values. So the given values are the distance of the object from the mirror is 10 centimeter, that is on the left hand side of the mirror, and the center of curvature is given as 30 centimeter. So the focal length will be half of the center of curvature, that is 15 centimeter. Now using the mirror formula, 1 by V plus 1 by U is equal to 1 by F. Here distance of the focal length is taken positive because it is on the right side of the mirror. And substituting the values, we get distance of the image as 6 centimeters. And this is on the right side of the mirror, so we take it as a positive distance. Now let's see the magnification part. So the magnification will be distance of the image divided by distance of the object. After putting the values, so we'll have 6 centimeter divided by 10 centimeter, which is 0.60. Now we can take magnification as height of the image divided by height of the object. So we need to find the height of the image. So now putting the values, we get height of the image as 0.60 into 5 centimeter, that is 3 centimeters. So both the image and the object are above the principal axis, and the image is formed on the right side of the mirror, so it is taken as positive. So this is the answer. Okay students, we'll close this session here. Please like, share and subscribe. Thank you.